Okay, so we had a couple of homework questions, and one of them was work that was to be done, and one of them was just kind of a what do you think kind of question. So the one that actually involved work was item 6.9, which is on the page 149 of the Whit and Whit book. So let's look at that, and if again, you may have some feedback on me if you've already submitted that already, but let's go ahead and look at that. I do want to do the problem. And a couple words about homework before I get into that is that, I mean, most of you are, seem to be submitting everything pretty well in good form and all that, but let me emphasize a couple of preferences at least, if not sort of cordial requirements. One of them is that it helps me if you submit things in PDF format. So if you're doing, if you're just typing out things narratively, that's fine. You can PDF that. Just save as PDF. Even if you're showing me the output window for SPSS, I think there's an option to save as a PDF because I know I've got some output windows in PDF format. So if you could just PDF everything that you submit to that Dropbox in terms of the assignment, that would be very helpful because, again, depending on what computer I'm using and where I'm doing this, I may or may not be able to read some types of documents, so if you'd PDF that. The other thing, again, and most of you are doing a great job of this, but it's easy to forget, but please put your name on every page. Because I may open up 5 assignments at once before I start recording grades, and as I say, you want me to be in a good mood and be able to find things, so I'm trying to give credit to somebody. So, and everybody, if you've got some of you submit things in 2 pages on 2 separate PDF documents, that's fine. But again, make sure your name's on each of those 2 documents or those 2 pages. If you do that, that would be very helpful. So let's look at 6.9, and that's in the Whit book, page 149. And it says, asks us to examine a pair of scores for X and Y. Doesn't tell what they are. We don't care. And we're supposed to determine the relationship, or as we call it, the correlation. Now, would like issues saving direct PDF. Suggestion was made that you can cut and paste into a Word document so that you can include that in the write-up, and of course then you can PDF that. Yeah, and you can copy and paste from SPSS output windows too, for that matter. So if that's what you're talking about, yeah, that does work. So yeah, there's at least an indirect way to do that. Okay, so we want to go to these pairs of data, and I'm going to start from scratch. I haven't entered any data, but we're going to do it the easy way. We're going to do it with SPSS, so give me a second to call that up and to make sure I can share this on your screen. Okay, so I'm going to open up, first of all, a blank SPSS window. And let me just kind of briefly go over. I'll do this pretty quickly because we've done it a number of times already. But let me just kind of step by step how to set this thing up. So you see a bunch of rows and columns, sort of like a spreadsheet. Well, it is a spreadsheet in a way. It's not like Excel exactly, but rows and columns the same kind of way. So to start things out, we are going to go to, I'm going to make this a little bit bigger. I think it'll be a little bigger on your screen if I do it this way. And can't tell if I expanded it much or not. I'm watching on my monitor and can tell not much difference. Okay, hopefully you can see it. It's about as big as I can make it. All right, so the first thing we do before we want to enter data, we've got to tell us something about the data. So if you'll notice the 2 buttons on the lower left of that window, Data View and Variable View, the default opens up the Data View window, or the Data View option. So before we put data in it, that's what Data View means. Imagine this, where we're looking at the data. Well, there's no data to look at. So we're going to go to Variable View, which is still going to give us a bunch of rows and columns. It's going to look a little bit different. So if I click Variable View, click, and I see still rows and columns, but I've got some different column headings here. So what I have to do is on the first row, far left, I'm going to identify what one of my variables is. And very unimaginably, we have x and y, so I'm going to put in x for my first variable. So I'm going to put in x, and as soon as I click off the cell, you're going to see the rest of that row and their default options. And click off the cell, there it is, and we're not going to fool with any of that right now. The next variable, which is the cell under the x, we're going to call that, again, very unimaginably, y. Click off the cell, I get the same kind of default values for the rest of the rows. So my variables are x and y. We identify them and do certain things with them if we wanted to, but we don't right now. And then I'm going to click back on data view. And what I will see in data view, where x and y are the first things in the first two rows, I'm going to see those x's and y's as column headings. Click column headings. So I'm going to put the x's under the x and the y's under the y. So I'm just going to, and it's just kind of a quick way to do that is fairly quick. I'm looking back and forth in my book, but that's okay. I use the down arrow. You can go across if you want to. Doesn't matter as long as it ends up looking like this when you're finished. And watch me and tell me not if, but when I make a mistake. Did I get any of those right? Did? How about that? Bet I can't do it again. Okay. Apparently I'm on a roll. All right, so those are my pieces of data. Notice they come in paired form for every x. It corresponds to a particular y value. That's what we mean by paired. The 64 first row, the 64 and 66 are paired together. And that can be like a pre-test or post-test or different kinds of things. Anyway, it's a correlation. So it can be a score on one test and score on another test. I don't know. Just data that comes in pairs. We'll talk about paired data more later. More later. We'll talk about that more later when we get into certain kinds of t-tests in the second half of the course. So I want to analyze this, so I'm going to go to Analyze. I'm going to click on Analyze, and I'm going to see a bunch of things in the menu underneath it. We're going to go down to Correlate, and when I point to Correlate, I see three options to the right, and we're going to go to bivariate because we're looking at a pair, the x and y paired together. Bi means two, so and we go to bivariate even if we had more than two variables. So I'm going to click on this. It's going to open up another window with two boxes, left box and right box. The left box includes my x's and my variables x and y, and I want to move both of them over to the right box, which means those are the ones it's going to deal with. So I move x and y from left to right. I'm going to click on options, and I'm going to ask for means and standard deviations. Get used to that because we generally report means and standard deviations, as I've mentioned. So I'll select means and standard deviations. I think I'm going pretty quickly because this is, we've done a number of examples, but that's okay. Probably going to do one more in a minute. Continue. And I'm ready to click OK. Leave everything else as it's defaulted to. It's a Pearson correlation. I talked about the difference between Pearson, for example, Spearman. We're always going to use Pearson for this kind of stuff right now. We talked a little bit about one and two-tailed. We'll get into that more later too. And I'm going to flag significant correlations. Remember, we had a discussion about what p-values mean and what levels of significance are, which again we will do a lot more with a little later. So I click OK. I'm going to get an output window, and there's my output window. And what I know from this is that my key information is right here. And again, that's the same box as the upper right, but I'm going to use kind of the lower triangle of things because that's kind of standard, because I mentioned a lot of statistical programs just spit out that lower triangle. I wish this did, and I wish it didn't give you duplicate information so I don't have to worry about what to do with. So I know that my correlation R is negative 0.914. That's a negative. It's pretty strong. I'll talk about that in a second too. Negative 0.914. So there's a pretty strong negative correlation. That means if a number is high in one column, it tends to be low in the other column and vice versa. The other thing is that P is equal to 0.001. So here's the thing about that again. If we say our correlation is significant, there's the word I'm using, there is a 0.001 chance that that's not true. And we'll talk about different types of error more later too, but anything under a p-value of 0.05 in our kind of research generally indicates significance. So we would call this a strong negative correlation. I'm going to write something in a way that I kind of want you to get used to because this is, again, a bit of a sneak, spoiler alert, bit of a sneak preview of coming attractions here. R parentheses 8 equals negative 0.914, comma, P is equal to 0.001. This is the way we write up the results of a correlation. It's R because that's what the R value is. Where does 8 come from? Anybody remember that? Yeah, that's the degrees of freedom. It's 9 pairs minus 1. So 8 degrees of freedom equals the R value, which is the negative 914 there, and that we can pick out from the output window. And then the p-value is called our significant two-tail. Again, we default to two-tail, but we're not going to change that for right now. The p-value is 0.001. So this is the way we write it. I bet that you have found studies in research articles you've written where you've seen things like this and you kind of wonder what that's all about. Well, let's just keep reading on because I have no clue. Now you have a clue. So that's the way we're going to write these up. And we've got a series of 4 APA write-ups that are assigned for this course, and writing one up on a correlation is the first one. And I've got a more specific example about all the words that go around that too. But that's the heart of the communication of the correlation, what it is and what it means. Questions. Somewhere, when you turn your homework in again, I want to see where you get your answers from, which would be the output window in this case. A couple of you brave souls work this out by hand. Don't do that. I'm too lazy to do that. I encourage you to be the same degree of laziness. So what I'd ideally like to see is the output window and tell me what the answers are. I mean, don't just show me the output window. I need to know that you know what to look at to get the answer. So if you were to say, if I ask you what the correlation is, you need to say this. There you go. Well, you need to say that specifically somewhere, because I see a bunch of numbers on that page. And I think everybody did. So I'm not even fussing anybody for anything, but just make sure, again, show your work and tell me what the answer is. It's the old math teacher. Any other thoughts, questions about this particular question? If not, let's talk about 611. 611 is kind of a what do you think question. And the idea is that we've got a correlation, 0.8, which we probably, again, I don't have the p-value of that, but and it's certainly positive. I would guess normally that's a probably fairly strong and significant correlation. So that's the relationship between food intake in ounces and body weight in pounds. If we change measuring from ounces, food in ounces to body in pounds, if we changed from food measuring in grams and pounds of weight measured in kilograms, would that change the value of R? Some of you said yes, some of you said no. Make a case one way or the other. Yes or no, and why? Some of you may have even gone to the extent, and I've done this in class before, of kind of making up a little some data and changing them appropriately and run the correlation both ways. Still hearing okay? Okay. Did you do that? Okay. So what did you find if you did that? I got the same. It is the same. And here's kind of a real world way of explaining that. And some of again, some of you said yes, some of you said no because you're measuring differently or things like that. It's the same. It's the same question as saying if you give a temperature in Fahrenheit and then you give the same temperature in Celsius, it's the same temperature. Just because you change the scale doesn't change the temperature. So just because you change the way you measure doesn't change the weight of either the food as intake or the weight of the eater. So yeah, it's going to be the same because the relationship's the same. The data, even though they're measured differently, um, they're still going to keep the same relationship. Any other thoughts and questions about the homework? I think before I leave this, I want to go back and do one more example. I told you I was saving one that I might come back and do. I think I do. I think I have decided I wanted to go back and do that. If you'll look at Green and Falcon on page, I'll give you a second to get there. The end of lesson 31 on page 264, and call up the data from lesson 31, exercise 2. Lesson 31, exercise 2. I'll put that on the screen. You can see what it looks like. See if you've got that here in just a second. The question is, could you call up the data directly from SPSS? Do you mean SPSS or the file on the D2L side? Yeah, if you're in SPSS, you can go to File, Open, find wherever that is, and I encourage you. You may want to even. Though I've got all these files that we're using as examples from Green and Falcon, I've got them on the D2L side. You may want to actually copy and paste them, say, onto a flash drive or something, so you can get to that without having to go through the D2L side. Okay, what I want to address is question number 7, but I'll wait till you get there. Lesson 31, exercise 2. Okay, still loading. Okay, you got anybody still loading, or do you? Okay, so we've got some data. If you're still loading, still load while I talk about this a little bit. I've got a bunch of GPAs. I've got a math GPA, an English GPA, a history GPA, a science GPA, a sociology or social sciences GPA. Okay. If I want to, I will do number 5. If I want to do number 5, conduct a correlational analysis to investigate the relationships of GPA in math and science with, let's not do that. let's skip down to, let's skip down to, yeah, create two new variables is what I want to do. Okay, we've not created new variables, have we? I think we talked about that we could, but I don't think we've done that, have we? Okay, I want to create an average GPA in math and science. I've got my GPA in math, I've got my GPA in science, so for the first row, 1.98, 1.98, and a 2.46, I want to average those together. So do I need to go back to data view and create a new variable here and then go back through up here and add the math to science and divide by 2? And so please say no, because I don't. Okay, I'm going to create a new variable from information I already have. So I want to go to transform. So maybe you're still loading. Maybe should I give you another minute or two? Because I do want you to walk through this with me. Of course, if you're watching the recording, you can just pause or stop for a minute. Gail, are you still loading? Are you there? No luck? If you're trying to use this on the Citrix, the XEN site, you have to go through that little thing I showed you the video about from Dr. Lampa, where you got to save it on the S drive or whatever he says you have to do. So I just will help you if you need help on that, but otherwise I need to go ahead and proceed. So I'm going to transform. I'm going to select compute variable. And I can call this new variable whatever I want to, but I've got to obey the same rules. It won't like it if I use spaces, things like that. There we go. I think I can use caps and lowercase. So I'm going to call it Math Science Average GPA. How's that? So my Math and Science Average GPA. So what I want to do, how do you take the average of something? You add them together and divide by 2. So I want to add the, and I'm going to open up a parenthesis here. And inside the parenthesis, I'm going to take Math. So double click Math, or you can click it and move it over on with the arrow. Plus on my keyboard, Science, and that's in parentheses because I want to add those first, and then I'm going to take whatever that total is, divide by 2. So the slash symbol is the divide symbol, which is what a fraction tells you to do anyway. So divided by 2. So math GPA plus science GPA divided by 2. There are all kinds of mathematical functions on the right that you can choose without actually kind of plugging them into a formula like we've done. Like there's a mean option here, which you could do the same way, but I'm just kind of do it the way that makes excuse me I think makes the most sense for now. So when I click OK, it's going to go back to my data view unless it tells me the illegal character. I do it like something. Oh, I know what it was. It doesn't like that slash here. Okay. Now when I click OK, it's going to go back to my data view, except for that telling me that an output when it did something. I don't want to save that. Now I've got a new column. Math Science Average GPA. So for that first person, or the first row, 1.98 plus 2.46 divided by 2 is going to be 2.22. You can check it if you want to. I don't have to, I know it is. So that's one new variable we created. Another new variable, it wants the average and the average GPA in social science and humanities. So I'm going to go back to transform again to compute variable. And it's going to leave everything the way I had it, but I don't like this stuff because I want to do something new. And this is going to be, what do we say, social science and what? Social science and humanities. So SOC and HUM. What's humanities? Must be history. And that's going to be the social science, parentheses, social science plus history. I don't know if they probably want us to include English too, but that's okay. We'll just say it's social science and history. And we're going to divide that by 2. So I just click on the rest of my calculator keyboard there. And if I've not entered in an illegal character, I should see that as another column heading. And yes, an output window saying you did something. Okay, fine. And sure enough, it is. So now I want to know what the correlation is between math and science GPA and the sociology or social science and history GPA. So I'm going to go to Analyze, Correlate, Bivariate, and again I have all those variables, including my new ones on the left, but the only ones I want are the math science average GPA and the social studies, social science history GPA. Those are the only 2 I want. I could ask for all of them, but that's what I'm asked for to do in number 7. So I'm going to move those over there. I'm going to click options because remember I want it to give me also means and standard deviations. And I'll point that out a little more when I get to the output window right now. Okay, so my correlation is 0.182. My p-value is 0.046. Now this is clearly positive because 0.182 is positive. But it's also strong or significant because p is less than 0.05. Again, we've got less than a 5% chance of being wrong if we say it's significant. So that's small enough chance to be wrong that we're going to go ahead and say so. Okay. So does that make sense in terms of how to, and we'll do this in some examples as we go along throughout the course, but to take information you have and create a new variable with whatever mathematical gymnastics you want to do with the numbers there. We could have had an average of everything if we wanted to, add them all together divided by however many we had. So if you've already got the information there and you're going to base something else on it, you don't have to start from scratch. Again, take the easy way out. Let that do the work. So we're okay with closing off correlation for now and homework questions and the other example we've done today. Okay.